Alright, we're going to finish up with graphing rational functions. It says state all asymptotes. That would be vertical, horizontal, and possibly slant asymptotes. Any holes in the graph, and also give the domain, and then it asks for you to graph. Well, you have to look here in the denominator to see if you have any vertical asymptotes. Now you also have to look in the numerator at the same time, because if you find a value that makes the denominator equal to 0, and x minus 4 is equal to 0 when x is 4, you have to see if x of 4 also makes the numerator 0, because if it makes both the numerator and the denominator 0, you have a hole in your graph. You don't have a vertical asymptote, but it only makes the denominator 0, so I have a vertical asymptote at x equals 4. Now when I look at just this part, forget about the plus 2, that just raises everything up to. If I look just here, I have equal degree in the numerator and denominator, they're both degree 1. And the coefficients are 1s, the lead coefficients. So the the horizontal asymptote is the ratio of the lead coefficients. That'd be 1 over 1, which is 1, but I have to move everything up 2, so y equals 3 is my horizontal asymptote. There are no holes in my graph because there are no values that make both the numerator and the denominator 0. There are no slant asymptotes because the degree of the numerator would have to be 1 bigger than the degree of the denominator for that to occur. So now I need my domain. Well, my domain is everything but 4. So you can write that the domain is the set of all x such that x cannot equal 4, yet x is an element of the real numbers. Now I know that your instructor probably shows it a little bit different. Soon you'll be doing interval notation. Interval notation looks like this, from negative infinity to 4, and from 4 to infinity. The parentheses means you don't include the 4. But that's down the way. So now what I need to graph this is I need to start off by graphing my vertical and horizontal asymptotes. Remember, these are dotted lines. So x equals 4, 1, 2, 3, 4, that'd be right here. Line it up as neatly as you can. And make a dotted line. Whoop. Try not to move your straight edge. Put arrows on the ends, and y equals 3 is a horizontal line right here. 1, 2, 3. Whoop. Again, try not to let your straight edge move. And there it is. And it breaks it into 4 regions, of which most likely this is going to be in 2 of the regions. Now, to help me with this is I need a bunch of points to graph. So this is probably the least favorite part of working one of these problems out, is to make a T-chart. And I just happened to make a T-chart in advance. There we go. And I picked values. I didn't want to pick 4, but I wanted to pick numbers smaller than 4 and bigger than 4 and close to 4. So I picked a bunch of them. 0, 1, 2, 3, 3.5, 4.5, 5, 6, and 7. That should be enough to get a halfway decent sketch. Now this is going to slow you down when you're taking the test. So if you need to omit a couple of them, maybe. But I certainly try to get the ones that are close to it to see how it reacts with the graph and with the asymptotes. So I plug these into this equation, or this function, one at a time, and I have negative 5/4, I have 2/3, I have negative 2/3, excuse me, I have negative 1/2, I have negative 4, I have negative 11, and then I have 17, 10, 13 halves, which is 6.5, and then 16 thirds, which is 5 1/3. Now you can plot more points than that, but this should give you a rough idea of what it looks like. And so I'm going to pick one of the markers here, colored markers here. I'll use the pink, and I'll graph 0, negative 5/4, it's a little bit smaller than negative 1, 1, negative 2/3. I'm going to pick well, all of a sudden I don't like this one bit. This doesn't look anything like what I thought it was going to be. 0, negative 5/4, negative 1/2. I get 2, negative 1/2. Well, did I write down the right one? I may have to do this video all over again if I screwed these numbers up. Oh, I hate when I screw up. Alright, so if I plug in 0, I get negative 3/4 plus 2 is positive 5/4. Good Lord, no wonder I couldn't get these to work out. These are probably positive numbers here. Well, we'll find out here. This one's positive, but if I plug 1 in, I get 4 thirds, negative 4 thirds. Yeah, that's a positive 2 thirds. If I plug 2 in, I get 5 over negative 2. That's negative 5 halves. No, that's minus a half. If I plug 3 in, I get 6 over negative 1. That's negative 6 plus 2 is negative 4. I think those rest of those are right. If you don't plot these points right, you're in trouble. So 5/4 would be about here. 2 thirds would be about here. Here we go. 2 negative 1/2 would be about here. 3 negative 4. 3 negative 1, 2, 3, 4 would be about down here. And can you kind of see a curve here? Now, if I plug in a number over here, I'll see it come up a little bit closer to this line y equals 3. But I think I've got enough points to kind of get it now. This one was negative 11, would have been down here somewhere. Okay? And I will probably put arrows on the ends like that. Then to get the other part of the graph, and hopefully I didn't mess up with these, at 4.5, I'm up at 17. That's way up here somewhere. And then I'm at 5/10. I'm at 6. This is 6.5. So 6, 6.5 would be about here. Then I'm at 7. This is 5 1/3. 7. This is 5 1/3. And you can probably see how it's coming down. Oops. And it's going to do something like that. Okay? This is something that you're going to want to practice. You don't want to just do one of these 2 or 3 days before you take a test on this. You want to practice this the night before and maybe even the morning of, so it's in your head. And there's my graph. Yikes. Almost messed that one up royally. Okay, so the next one up is this guy here, and he's kind of a special guy in that, notice here that the denominator factors, and one of the factors is the numerator. So you're tempted to kind of cross these out and write this is 1 over x plus 4, and that's what happens. This guy here is actually the graph of this with one exception. It happens at 4. See, 4 is defined here, but it's not defined here. So as part of my domain, x cannot equal plus or minus 4. So my domain would be the set of all x such that x cannot equal 4 plus or minus 4, excuse me, and x is an element of the real numbers. But I only have one vertical asymptote. My vertical asymptote is going to be at x equal negative 4. So you say, well, what happens at positive 4? Because that gives me 0 in the denominator. Well, it also gives me 0 in the numerator. So I have a hole in the graph when that happens, and that happens when x is 4. Now, not the line 4, but the point when the x value is 4. In fact, if I plug 4 in here, I would get 4, plug 4 in here, that would be 1/8. So now, I'm going to try to come up with a table of values here, x and y, and my key here, I need to also put in my my asymptotes here. Now notice that the degree of the numerator is smaller than the degree of the denominator, so I have a horizontal asymptote of the x-axis, y equals 0. Whenever the degree of the numerator is smaller than the degree of the denominator, you have a horizontal asymptote of the x-axis, which is the line y equals 0. So now, time to get my straight edge here. Time to put my asymptotes in. Now these are dotted, so I don't know if you're going to be able to see this very well. I probably should use a different color, but I'm going to have this line, and I'm going to have x equals negative 4 right here. Oop. So now, I'm going to graph this thing, and to graph this thing, I do need a table of values, a t-chart of values here. So I picked, again, I wanted to center around negative 4 here, so I picked negative 7, negative 6, negative 5, negative 4.5, negative 3.5, negative 3, and I went all the way down to 0. And I plugged these numbers in. Let's see if I got them right this time. I got negative 1/3, I got negative 1/2, I have negative 1, negative 2, 2, negative 1. Or is it positive 1? No, it's positive 1. 1/2, 1/3, 1/4. And you say, well, how'd you get those to come out so nice? Well, you don't have to plug into here because you're not plugging in anything that makes the denominator 0. Plug it into this form. It's a lot simpler to plug in and simplify. So -7, let me get a different color here. Do this one in green. So -7, -1/3. 5's right there, -1/3, about there. -6 is -1/2. -5 is -1. -4.5 is -2. Hopefully you can see this green coming right there. Oh, not supposed to touch the asymptote there. And then if I continue graphing at -3.5, I'm at 2, -3, 1, -2, 1/2, -1, 1/3, and 0, 1/4. Now, the point of interest that you're going to need to keep track of, remember you have a hole in your graph here. So this is at 4, let's see, 1, 2, 3, 4, 1/8, it's going to look like a hole right there. So my graph is going to continue up like this, and it's going to continue down, continue down, and you have a hole in the graph like that. Now you should make this 0, this little hole here, big enough that you can see it. Because if you don't, then your person who's grading your paper might not see it and might not give you credit for that. All right, that's the first two graphs. They're fairly interesting. Now, because I'm lazy, I'm going to graph the next two, but what I'm going to do is try to keep these same sets of coordinate axes. So I'm just going to erase a little bit here and see if I can sneak this stuff in without having to reinvent the wheel and have to graph these, put these number lines out all over again. Okay, that one's not too bad. And then this one here. Well, let's see, this is not going to be great because it's so close. Probably going to see a little green in this one. Oh, and I erased the wrong axes. Ah! What a catastrophe. Alright, so I'm going to get the thumb to action there. Let's see if I can salvage this by grabbing my trusty yardstick and drawing at least the top part of my y-axis back in there. Doggone me. And let's put the scale in. Well, you can see why I wanted to save this, because it's a hassle to draw these out a bunch of times. 2, 3, 4, 5, 6, 7, 8, 9, 10. That'll be good enough. Okay, there they are. Let's see if we can come up with the graphs for 19 and 20. Let's see, 19 was f of x equals, now they put the negative in front, that's easy to lose, so I'm going to put it up by the 8, and that's all over x squared plus 4x minus 5, but I'm going to factor that. I prefer the factored form so I can find my vertical asymptotes a little bit more readily, so that'd be x plus 5 times x minus 1. And because the degree of the numerator is smaller than the degree of the denominator, my horizontal asymptote is the x-axis, y equals 0. My vertical asymptote would be at -5 and +1, so x equals -5, x equals +1. My domain would be all numbers except for those, so that would be the set of all x such that x cannot equal -5 or 1, yet x is an element of the real numbers. And I think that's all the data that they want here. There are no holes in the graph because there are no values that make the numerator and the denominator 0. So now we need a graph. Now once again, this one's a peach. You could spend a long time find in ordered pairs. You need to have your calculator with you. All right, my key values here are -5 and +1, and they're fairly apart. They're 6 apart. So I got a crud load of values here. You may not have time to do all of these. You may have to skip some of the ones that are especially in the middle between -5 and +1. So I have them all in here because I had extra time. So that's 0.0, 0.5, 1.5, 2, and 3. I plug these in. I have -8/27. I have -1/2. I have -8/7. I have -32/13. Then I have a +32/7. I have 8/5. I have 1. I have 8/9. I have 1. I have 8/5. I have 32/11. Then I have -32/13. I have -8/7. I have -1/2. Holy moly. Now, let me set this down. I want to draw in my 3 asymptotes here. I tell you what, I'll put the asymptotes in a different color this time. Maybe you can see that a little bit more readily. Let's try the purple one here. So I have y = 0. That's the x-axis. Try not to let your straight edge move too much, like I'm doing. There's one of them. And then x = -5, 1, well right there it is, -5. Make it look vertical. Now because I have 2 vertical asymptotes, I'm going to get 6 regions, and of which I'm going to probably use just 3 of them. X = 1 would be right here. Okay, and you can see 1, 2, 3, 4, 5, 6 regions. Time to get some points graphed. Let's use the black marker here so you can see it a little bit more readily. Now this is a little bit smaller, actually a little bit bigger than -1/3, a little closer to the x-axis. So I have at -8, 1, 2, 3, -8 right here, negative about here, I'm approximating. Then I have -7, -1/2, that's down just a little. Then I have -6, that's like -1 and some change, so about here. Then at -5.5, that's like between -2 and -3, probably about here. And you see how your graph is looking? Whoops. Make it look like a nice smooth curve. That's this part of the graph. Okay, then I graph these points, -4.5. That's about 4.5 there. 1, 2, 3, 4.5 would be about here. Then I have -4, that's about -1.5. There's a big jump down. Then I have -3, +1, that's about here. -2, -8/9, that's just a shade below +1. Then back at here to 1. And then at 0, 8/5, 1, 2, 3, about, wait a minute, hang on, 8/5, about here. And then at 32/11, that's not quite 3, I'm at a half, 1, 2, 3, about like this. Do you see your curve here? It's going to look kind of U-shaped. It's definitely not a parabola. And be careful with this. Now I'm freehanding it. And so I'm probably not going to make it look as good as it should. But it's going to be something like this. Now that's all this stuff here. Now these ones, I only have 3. I might need to plug in another one. 1.5, that would be about -2.5. Give or take. Approximating that. About a little smaller than -1. And then -1/2. You see the curve right here? Kind of matching this guy. And it's going to go like that. Now that's a lot of points, like I said. And if you're running out of time, you may not have the ability, even with a calculator, to get all those figured out. So you need to kind of be careful about pacing your time out. This one's number 20, which I set down over here. Now this is the one that has the slant or oblique asymptote. I have f of x is equal to x squared minus 3x minus 4 all over 3x. Because the degree of the numerator is greater than or equal to the degree of, greater than the degree of the denominator, there is no horizontal asymptote. But because it's 1 greater, there is a slant asymptote. You divide 3x plus 0 into x squared minus 3x minus 4, whatever the quotient is, not the remainder, the quotient, that's what you're going to use to find your slant or oblique asymptote. It's going to be y equals the quotient. Now 1 times 3x gives me x squared. It's weird, but it's 1/3 x. 1/3 x times 3x is x squared. 1/3 x times 0 is plus 0x. So I subtract, right? That would give me negative 3x, and then I bring down the minus 4. What times 3x gives me negative 3x? Well, that's negative 1. Negative 3x plus 0, and that's going to be my remainder. So I have a slant asymptote of y equals 1/3 x minus 1. I do have a vertical asymptote because 0 makes the denominator 0, but not the numerator. So my vertical asymptote is x equals 0, which is the y-axis. So again, I'm going to graph those real quick. I'll use the pink this time for my 2 asymptotes. So x equals 0 is right here. Oh, be neat. Bring a straight edge. When you take this, otherwise you're freehanding everything. Nope, wait a minute, one more. My slant asymptote is the line y equals 1/3 x minus 1. Now this is not vertical horizontal, this is slanted, it's got slope 1/3. Notice the slope-intercept form. My y-intercept's at 0, negative 1. My slope is 1/3, up 1, 1, 2, 3, to the right 3. And make sure that you set this up also as a dotted line because it's an asymptote. Okay. And I need a table of values, but I do have 1, 2, 3, 4 regions. My graph's going to be in 2 of them, but without a table of values, I am guessing where they go. And I made a table of values somewhere, if I can find it. And there it is. Now, the key here is that I don't want an x value of 0, but I want some values that are close to 0, so I want negative 4, negative 3, negative 2, negative 1, negative 0.5, 0.5, 1, 2, 3, and 4. And I plug those in. Oh, there goes the other paper. Plug those in one at a time. And here's what I got. I got negative 2, negative 14 ninths, negative 1, 0, 3, negative 7 halves, negative 2, negative 1, negative 1/3, and 0. So now I'm going to plot those points. So negative 4, negative 2 is just barely above the line, the dotted line. Negative 4, negative 2, negative 3, this is like negative 1.5. So that'd be about here. This is negative 2, negative 1, that'd be about here. Then I have negative 1, 0, that's right here. And then negative 1/2, 3. Be about here. Do you see your curve here? It's hugging it. Oops, it's hugging it, not touching it. And then it kind of bends right up there and gets closer and closer and closer. So I'll bet you a quarter that the rest of my graph's over here. I've done this much. Let's do this part. So this is 1/2, negative 3.5. 1, 2, 3.5, that'd be about here. 1, negative 2 would be about here. 2, negative 1 would be about here. 3, negative 1/8 would be, negative 1/3, excuse me, would be about here. And then 4 zeros right here. You see how it hugs the graph? There we go. And we get our graph right there. And that one's a peach. Now I can't graph these things just by the looks of the equation. I have to find my asymptotes and I have to plot some points. Finding the asymptote, oh, by the way, I did not give the domain, but the domain for this one would be the set of all x such that x cannot equal 0, but x is an element of the real numbers. Okay, don't forget to answer all parts of the question. So I hope this helps. And of course, practice, practice, practice.